Welcome back, everybody. Just give it a second or two more to see if there's anything else in the waiting room. Nope. They're all flooding in, Brian. Look at that.
All right. Sounds great.
Yeah. So welcome, everybody, back to the security stream. It is now 1:30 UK time, and we're up next with our second session of the day for security. So it gives me great pleasure to welcome Brian Childs from IBM. He's got a very catchy title with this session, right? Anti Malware for zOS. What does it mean? So more about that in a moment. Really looking forward to that. Just a couple of quick things to know before we get started. Don't forget your feedback. I will remind you at the end, if you've been attending sessions this morning or you've got a backlog from yesterday, don't forget to complete those, because that's important for us as well as a presenter, and also for CPE points if you are collecting those. And one other thing I would say, Brian doesn't bite, by the way. He's a lovely chap, and we were fortunate enough to have him at the conference back in November, weren't we, Brian? You did some sessions for us on the security stream.
Yeah, that was great fun.
Yep. So don't forget to post questions in the chat. It's there. There's no such thing as a stupid question in this community. So please do post. And we will read them out at a convenient moment, because Brian will be taking questions throughout. And at the end, if there is time, then I'll unmute the line, and then you can fire a question live at Brian if you so wish. So Brian, without further ado, welcome back, sir. It's lovely to have you with us, and the stage is yours, sir.
Okay. Thanks very much, Jamie, and welcome everybody. I cannot see you at all, but hopefully you can see me, and we're going to have a fun conversation today on anti-malware for zOS. I'm Brian Childs, Principal Product Manager for zOS Security at IBM, and here we are at session 8J, and let's get started. One thing that my colleagues here at IBM humor me quite well. I like to give kudos to all the different SMEs out there in the security space that help me understand and develop a lot of these functions. And so in this presentation today, we are going to get insights from all of these people. They humor me in allowing me to create cartoon caricatures of them. So these are the avatar cards of the SMEs that we will hear from today. So we've got Diane Stamboni, who is the product owner of our zOS authorized code scanner. We've got two DEs represented here. So you've got David Peterson on the GDPS resiliency side, and Mike Jordan, our DE for IBM Z Security. You've got RACF expertise from Eric Rosenfeld. You've got Ben Siegel, SDSM from IBM Z Research. You've got another SDSM, Chris Meyer from the network side, David Rossi, cybersecurity architect extraordinaire, another representation from Nathan Bryce in the GDPS space. Anusha Didwania, many of you already know from work that she did in the ZCC and other zOS projects before that. She is our anti-malware SME in terms of this particular topic. And last but not least, another mentor of mine for quite some time, Peter Spera, SDSM from the IBM Z Center for Secure Engineering, for all you fans out there of the security portal. So without further ado, let's see what these SMEs have to share with us today. We are going to start with a particular statement of direction, titled no less, Anti-Malware for IBM zOS. So we at IBM issued this last fall, and here's the link in this particular deck if you want to look at the full text. And we're going to have a couple of words of emphasis here on this slide, and then we're going to unpack it in the slides that follow. IBM plans to provide a software solution that introduces cyber anomaly detection to provide the option of quarantine functionality to satisfy compliance regulations requiring anti-malware for the zOS platform. So essentially, in that excerpt, we have three parts here. We have the creation of anomaly detection, the creation of quarantine function, and then combining those two together to be able to declare anti-malware. So that's our initial feed from Anuja and where the direction of this overall project is going. So let's start to unpack that. And if anybody has questions or comments along the way, be sure to put that in the chat, and Jamie or Sue will let me know, and we'll directly go into that. Interruptions in this discussion are totally fine. So we'll start with a somewhat baited question. So we can have this as an informal poll and see if anybody reacts. But can anybody guess if we're going to have a side discussion, a related discussion with regard to integrity scanning for the authorized program facility? What is the top question that might arise for said scans? So here we're having this insight from Dan Stamboni, who is a product owner of Zax. And as you're aware, there's a couple different integrity scanners out there, specific to zOS, looking at potential vulnerabilities that could exist in your APF load libraries. IBM has this one optional price feature, and then KRI, now part of Rocket Software, has another option. So from a general security integrity perspective, we do recommend that the clients choose one and look to see where there might be some increased integrity patching in some of the most critical software that resides on zOS. But here are our three choices of this informal poll. Is the top question from our clients, can we scan program calls and supervisor calls? Or is the most popular question, can we scan AC1 linked modules invoked from batch or USS? Or is the most popular question, can this count as antivirus software for our next audit? So Jamie, do I have any responses from this particular not so tricky question?
Not at the moment, but just everybody, just if you want to make this interactive, we'd be very grateful. Just pop a number in from that slide there. So I'm going to go. I'm going to pop in. I'm going to go for 3. I just had this feeling, knowing auditors, that that's one of the questions that if they're not so mainframe savvy, they might ask. Yeah. Oh, so we've got 2s. We've got some 3s, a few 3s there. Looks like it's a bit of a mixed bag there, Brian.
Okay. So we do have some answers coming in for 2.
Yep. 2 and for 2, and well, some say 2, some say 3.
Okay. All right. So we won't ask for the complete rundown, but since people are floating the possibility of 2, technically, in the perspective of Zax, that can be done. I'm not an expert on KRI's offering. You can double check with them and their associated services. Certainly, both 1 and 2 are relevant for looking at the integrity of your APF load modules. But in the various conversations I've had since Zax launched back in 2020, I will say definitively, question number 3 has been the top question. So for those that answer 3, including you, Jamie, that is the accurate response in terms of what's been the most popular question to date. Okay, so from here, we're going to go make some references to some various definitions, and we're not going to go just from an IBM context of things. We're going to check in with NIST. So here we're going to be checking in with Peter Spera, who unofficially runs the security portal, and we have some definitions straight from CSRC NIST.gov. What does NIST consider a vulnerability? A weakness in an information system, system security procedures, internal controls, or implementation that could be exploited or triggered by a threat source. Whereas, if you look at the same glossary for the definition of a virus, NIST describes that this way: a hidden, self-replicating section of computer software, usually malicious logic, that propagates by infecting, i.e. inserting a copy of itself into and becoming part of another program. A virus cannot run by itself. It requires that its host program be run to make the virus active. Okay, so what's the significance here? One, when we are looking for integrity vulnerabilities, that is most certainly not the same as a virus. And furthermore, a virus is a very specific kind of malware, right? So you've got to have something that is, by its nature, self-replicating. It has to have an existing piece of software to latch onto, and it behaves in a certain way. Historically, on distributed systems, a specific virus can be recognized with a given signature, and that's where antivirus software has historically been done, right? If you've confirmed that a certain kind of virus runs on a distributed system, then you go search through this database of confirmed signatures, and you look for that signature in your code base. So on zOS, we literally know of no instance of a virus that has ever been done on the platform. And so every time this has come up, as over the years, the question has come up a number of times from different areas of the company. Sometimes it comes through the security portal. Sometimes it will come to our executives or to product management, and they'll say, do you have something here for antivirus? Well, no, because we don't have a signature to look for. And then often the corresponding question that can sometimes come up is, well, IBM, could you then issue a statement that it is impossible for a virus to ever run on the mainframe on zOS? Well, we can't say that it's impossible. We don't know of any instance. And so then our clients continue to have these kind of tricky discussions at times with the regulators, because you don't have antivirus software to reference. You can't guarantee that a virus can't run, and so then there's this gap. So over the years, there hasn't been an easy answer to that. We certainly recommend different kinds of scanning, and integrity scanning on the APF, certainly very worthwhile. Other types of scanners that are, let's say, higher up in the stack, from network scanning, web application scanning, Java source code scanning, all those are good, but they're all scanners. They're looking for these vulnerabilities. They're not looking for any form of actual malware. So something of interest started happening not so long ago with how we define anti-malware and the expansion from what has historically been an emphasis on the very specific type of malware known as a virus. So we'll go into this next slide. The NIST shift. How does NIST describe anti-malware? So I have this link to this fairly recent publication of Security and Privacy Controls for Information Systems and Organizations. And here's some excerpts. It provides clarification that malicious code protection mechanisms, they can include both signature, which you just talked about for the viruses, and non-signature based technologies. And further, this article goes on to say, non-signature based detection mechanisms include artificial intelligence techniques that use heuristics to detect, analyze, and describe the characteristics or behavior of this malicious code, and to provide controls against such code for which signatures do not yet exist, or for which existing signatures might not be effective. So this is a very interesting expansion. From a regulation perspective, it makes a whole lot of sense for the actual defending of your security posture, because now we're talking about any possible kind of malicious software. You're saying, please do leverage AI technologies, and then figure out what kind of mechanism you have controls against code once it's been identified, so that the risk is mitigated. But it's not just NIST that has made this expansion. If for those in the financial industry, if you have looked closely at the PCI DSS 4.0 regs, and that went public not so long ago, and of course I think it roughly doubled in size from the prior version. But one thing that we notice quite quickly is that PCI 4.0 no longer references antivirus software specifically. It has shifted completely to anti-malware, and it mentions it over 50 times. And in kind of in lockstep with what the NIST definition has, the PCI regs now include non-signature based detection when combined with blocking and or quarantining of the malicious software. So you have the full link here, but you put those two things in conjunction, and this is a very significant shift because this is something where various areas of zOS are already, looking into this strengthening of a security posture, and now coincidentally, it looks like we're going to have a way to finally, quote unquote, check the box for regulations to simplify upcoming audits. Okay, so it's not just PCI with regard to the regs. Since this is the GSE, it seems appropriate to mention DORA. I think everybody is fairly familiar now. Here is another set of regs coming due in the same quarter of next year. And if you look at the Digital Operational Resiliency Act, you see that it mirrors the NIST cybersecurity framework fairly well, in that you've got this convergence of, let's say, traditional security with resiliency. If you look at just the opening paragraph on their main site, right, the Digital Operational Resiliency Act solves an important problem in the EU financial regulation. Before DORA, financial institutions manage the main categories of operational risk, mainly with the allocation of capital, but they do not manage all components of operational resilience. After DORA, they must all also follow rules for the protection, detection, containment, recovery, and repair capabilities against ICT-related incidents. So include the link. Of course, you probably already have this link already, but here we have this heads up from Nathan Bryce, program director at GDPS, because now what we're looking at for the notion of anomaly detection plays its part for the upcoming claim of anti-malware, but also has a direct relationship to this notion of detection for compliance in DORA. Right. So following up a little bit more on GDPS, coincidentally, there is this corresponding statement of direction that came from them. And here we'll quote DE Dave Peterson in this SOD. IBM intends to extend GDPS LCP Manager to consume event notification from the anti-malware solution for zOS described in that other SOD. And so we have the link and the page number for where this is mentioned. So the whole point here is to say this is something that is going to be readily integrated with other piece parts for your overall security and resiliency. That when whatever you use as a detection mechanism, you can now put together, let's say, with your whole cyber vault strategy and how this is going to maximize the functionality you get, let's say, from safeguarded copy on the DSAK. Any questions or comments there so far?
Nothing in the chat at the moment, Brian.
Okay. I'll keep going. This next chart, this is just high-level blueprint. I'm sure you've seen this in various forms before, but I thought in this context, really good to review. So the safeguarded copy blueprint and the topic of discovery, right? The context of this whole AI-driven discovery of a potential incident, right? So you've got your production system, you've got your cyber vault system, you've got these immutable copies, and you are, at whatever interval that you have chosen, when you get to the spot where you are, you believe you have an incident and you are now in response to that, you're going through to figure out what is the most recent copy that has not already been corrupted. So this is something that has been coming up with clients over some time now to say, okay, they're determining how frequent to take all these copies, but also wondering what might be possible in the area of discovery. So you shrink the window, right? So you have a quicker response time. And so that's this relationship we have with the SOD, GPS, LCP, and the notion of detection of some anomalous event that could mean some form of real-time cyber attack. So this is where these pieces can then interconnect. So we're going to segue again here and get some advice from another cybersecurity professional, and we will hear from David Rossi, cybersecurity architect. I don't know if anybody has seen this before. Back in 2022, this is a definitive guide that the security division of IBM put on the historical data points around ransomware in the distributed area. So we get the reference point here. Of course, these are not Z stats, but it's good to see historically what ransomware attacks have occurred, how they occurred on distributed systems, so that we can look at the various security and resiliency function available on zOS to see how you might mitigate those different kinds and phases of attack vectors. So when we boil this down, and this is something that David did an investigation through, looking through the various aspects of that form, and first off, this is just it's almost obliged to us with any security presentation that we advocate multi-factor authentication. And that is something that comes out in all these different reports. You talk about the social engineering aspect of an attack vector. You can have wonderful education to everyone involved at any kind of enterprise to avoid links of social engineering attacks through email or text or what have you. But statistically, it continues to be a primary way to get into a system. And so when you're talking about the zOS as a system of record, very strong mitigation to have MFA as opposed to, let's say, an 8-character password, right? So very, very strong mitigation there in your security posture. When we're in this whole general discussion of post-incident response, it really is alongside a zero trust defense in depth kind of strategy, because you really don't want to get to the spot where you have an incident that you're going to be responding to. The significance is it's good to have a plan and to practice that plan, but to have the things in place, not only for the purpose of simplifying your next audit, but to have that range of strength in security and resiliency. So just doing a quick review of, let's say, the protection phase of your cybersecurity framework, which also aligns with DORA and also aligns with so many facets of PCI. Starting with MFA, after that, I'm looking at the enforcement of least access privilege. It's one of the fundamental principles of security. It's very easy to say. It can be quite tricky to do because it is a combination of tooling and business processes. Right? When you're talking about someone changing roles within their company, do you have those processes in place to go to the corresponding RACF access controls and remove them from various groups and remove their access to various resources? Because you have this risk of privilege creep as people get to increase roles to make sure that things still work. Right? There can be a risk there that says, well, as long as I'm just incrementally giving access to what they need to do, then maybe that is quote unquote okay. But you just recognize that the more privilege the various user IDs across your enterprise have, then the more risk you have whenever those the user ID might get compromised, or in the case of your insider threat risk. So verifying with MFA, enforcing with least access privilege, encrypting the data. And that's something that other presentations, I'm sure, have talked to as well, from the network perspective, as well as encrypting the data at rest. Certainly a big fan of zOS dataset encryption. Another side note on PCI 4.0 is that there's a note in the documentation that the regulators no longer consider self-encrypting disk to be sufficient, because of the fact that, well, if someone physically takes the storage volume away, well, yes, it's encrypted. But if you've got an attack from within the data center, that encryption has not helped you out. So we have heard from a lot of clients that the ones that didn't adopt data encryption already are taking a much closer look because of the change in these regs. But also to review a wonderful progression of enhancements by our friends in ComServer with regard to ZERT technology. And in case you haven't seen the latest, the nature of ZERT enforcement, also very popular with auditors. it makes your audit go that much more smoothly. So we've heard from a couple of clients who have already used ZERT enforcement, because you can claim truthfully that you have a minimum level of network strength when ZERT enforcement is put in place. So it's a great progression in the history of pervasive encryption. ZERT began with the SMF data, then aggregate data, then the ZNA as one way to look at that data to see what level of protocols and ciphers you're actually using in your network traffic, but also then segueing from that to, well, are there various applications that you want to move to ATTLS? So that is through policy agent, a simpler way to manage things overall. And then when you get into the ZERT enforcement, it's like that next level. Like, you have gone through the progression to say, what do I have? How do I use ATTLS to minimize or simplify the management of my network communications going forward? I don't have any more hard-coded protocols in my applications. And now I get to that level of confidence where I can put ZERT enforcement in place, and then be able to go into my audit with that level of certainty. Say, this is our minimum level of network strength, and it's a really great thing. So that's kind of the encryption bullet. Back to the topic of integrity, which ironically is kind of where we started this conversation with the notion of scanners, but also with regard to your policy from the security portal and from the communications you get from any of your vendors on any second PTF patch. Right? You have business decisions to make as to how quickly you apply these patches. Right? And so recognizing that a rolling IPL across all these zOS images is not a trivial thing, but because you have, let's say, the CVSS scoring system at your disposal to say how severe is the vulnerability that a given patch is mitigating, and how might that readily apply to your production systems, and how quickly can you get that rolled out across the board. That is another important aspect of your posture. And back to the nature of integrity scanning, for whichever offering you might try, then the integrity of the APF, because the APF programs being some of the most strong, powerful programs of the operating system, that it's in some of the documentation, it's akin to having the APF as an extension of the operating system itself, because it can do virtually anything. The integrity of the APF program's APIs, it really plays a critical role in the integrity of the whole platform. So that was kind of a quick review of mitigations that lined up with this historical look of ransomware attacks. And I would say that these four bullets you have probably heard over and over again, because these aren't necessarily new topics to your security posture. They continue to be very relevant and something to consider strongly for prioritizing in your next security project. But here we get to the spot where we say, okay, you have protected this to the best of your ability. What do you have, segueing into resiliency and recovery? What do you have for detection? What kind of investment do you have in threat intelligence? And if you ask, well, what is available today, given that most of this topic is about a statement of direction for something that is not available yet. Today, you can look into various SIMs and the connection of zOS SMF data into those SIMs, whether you are translating it into leaf mode to get to Splunk, whether it's to QRadar, any like full enterprise level SIM, so that zOS is not quote unquote invisible to your security intelligence. And so there are various clients who have tried this out, and they've started these communications with their SOC, or they've kind of taken the responsibility of the mainframe portion of the feed into the SOC. And this is kind of another reason why the need for AI security pops up, because it can be, depending on how you prioritize this policy-based way of doing threat intelligence and your SIM, it can be a bit of a fire hose of data. And so, what do you try to utilize future AI security functions for? Is that you have pinpointed events in which the AI has already given you focus points to go diagnose. And so enhancing that detection capability is a great way to connect traditional security protection from then the corresponding mitigation and recovery in case that there is an event. I'll pause right there. And then last but not least, and again, this is analogous to that ransomware report back from 2022 on distributed systems, is to test your backup policy, test your incident response plan. So this is just a natural progression of how you continue to strengthen the overall posture of zOS production systems. And coincidentally, it lines up with how a lot of the regulations are nudging the industry already. Okay, so that was kind of a mouthful. I'll pause there again. Any kind of questions, comments, feedback on this one?
Yeah, don't forget, folks, post your questions in the chat. There's nothing there at the moment, Brian, but I do have one quick question about the encryption side. So I'm still seeing some clients not kind of like doing a very good job of putting data encryption, like at rest aside, but like network traffic, some are doing quite a bad job in that area, like telnet traffic, for example, and FTP traffic still going in the clear. Is that something that you're seeing as well? Or are people getting better at it?
I would say that certainly the encryption of the network traffic, you think of it, if you make the analogy that your zOS production system is your house, and how are you going to lock down your house from the thief coming in to steal the precious information from your house? The notion of weak or non-existent encryption on your network traffic, or even the weak logon of a character passwords is kind of like not putting a lock or deadbolt on your front door, right? So we don't gather statistics or anything like that in terms of the different kinds of discussions we've had of projects that are not yet done, but it's something we do continue to advocate strongly, because the other aspect of the network encryption perspective is not just that it's the way in, right, from the outside, but it is also platform agnostic. So if you have let's say any kind of ransomware gang or threat actor that has some level of experience going after let's say the distributed systems world, then the whole protocol of TCP/IP, it's the same, right? There's lots of great ways in which zOS encryption is faster through the architecture with the CPACF and other means, that we have tremendous performance on the platform. But from the encryption itself, from the network side, the COM server's implementation, by its very nature, complies to the standard. So someone who has skills at hacking into weaker encryption methods, then those types of skills are going to translate. So it is definitely worth those security projects to put in place to make sure that you do have a very high level of network encryption across the board. So thank you for that question, Jamie.
No problem. We did have one question actually from, sorry, and forgive me, I can't pronounce your name. I'm going to say JavSec. So they ask, have you've been talking about TCP/IP so far? How about SNA's VTAM traffic encryption and policy enforcement capability?
Okay, very good. In terms of like covering the gamut, and I will not claim to be a network encryption expert. So I probably kind of defer some of that to, we can follow up with Chris Meyer and some of the other architects at a COM server. But I do know that there is the nature of both their work in TLS, but also with IPsec and other aspects of that network activity. I think all of it's valid. You know, there's no rules with regard to the nature of hacking, ethical or otherwise. So I think it's a very valid comment. I don't have a direct answer. And to your earlier comment, Jamie, I did want to also mention the importance of data set encrypting data at rest, given that it was purposely designed with AES-256, so it is considered to be a quantum safe encryption method, particularly for the regulations update of not accepting self-encrypting disk on its own. That does imply that clients are going to need to choose. Are you going to look at data set encryption at that file subsystem level, or are you going to look at application level encryption for the data at rest and then have to manage all these applications across the board? So it's another one of those combination of security and business challenge decisions. And it may find that particularly with our SOD, coincidentally, the same SOD that we referenced at the beginning of this discussion, we have the intent of coming out with a new offering for dataset key rotation to simplify that, not only from starting up dataset encryption, but then the subsequent rotation of keys and re-encrypting of those active datasets. So we have heard from customers with regard to key management and key rotation. Of course, we've got TKE for the HSM and master keys, UKO for provisioning and backing up operational keys, on top of the ICSF foundation there and its key stores. But we also have heard from a storage administrative perspective, looking for how to simplify how to do the encryption and re-encryption of all these data sets at scale. So that's something that is in the works also. Okay, so that was a lot, but I thought it was good to review and also to put context around this whole nature of detection and how that feeds into this upcoming claim for anti-malware on the platform. So I'll go to the next slide. These are some stats from IBM's data breach report that is done by the security division every year from 2023. Of particular interest when trying to make some kind of analogy, because of course these reports are all based on distributed systems and they typically have a lot less data than what we hold on zOS in the system of record, but they do have a section of what they call a mega breach. And the reports talk about anything of over 1 million records lost, they consider a mega breach. And then they do have average costs for, let's say, a breach over 10 million records. That skyrockets to an average of 150 million US dollars. So oftentimes we'll talk about single-digit million costs of a data breach statistically in the distributed space, but perhaps it's better to look at this notion of what a mega breach could mean if that would occur on a zOS production system. Other stats of some concern and related to this topic today: 277 is the average number of days for the respondents to identify and contain a breach. And they found organizations with extensive use of security AI and automation identify and contain the data breach 108 days faster than the organizations with no use. So in addition to helping out with your regs and improving your security posture, here are some stats that really nudge everyone to take a really good, strong look at security AI and how that can assist with your mitigation and response times in your post-incident response planning. And so now, next up, we're going to get some feedback and insights from Ben Siegel, SCSM at IBM Z Research. So these are just considerations, and I imagine there will be a number of offerings from the zOS ecosystem to this very, very important space. So considerations, possibilities for AI to mitigate your cyber attack risks. So we can make this an open discussion, but we have a couple bullet points for consideration. Is this security AI designed and built for zOS production environments? Right? Is it going to be customized not only just for zOS, but for your particular enterprise's environment? Do you have a lightweight AI that customizes to your workload? So in other words, is it going to be lightweight enough that it's not going to significantly impact, let's say, MLC costs on general processor use? Do you have customization such as exclusionless functionality as a manual tuning option? Some of early discussions on this topic, clients have said, well, that's great that IBM, you are developing this AI security for detection from an anomaly perspective, but false positives is something that is always going to be a topic for any kind of AI. And do we have the ability to manually tune it ourselves? Next question that can come up quite often: are there distinct artifacts output that are explainable and actionable? So it is one thing for the AI security to come back and say, something weird is happening that is different than your typical workload. But without the artifacts, then you're left with the question, well, what am I supposed to do about it? How does my diagnostic start? How do I begin? How am I supposed to know what to do if I don't have an area to focus the attention? So distinct artifacts is a very important bullet point of what we're looking at here. Also, are there integration points for notification and remediation? So we saw earlier there's this corresponding statement of direction from GDPS LCP as an example. Are there going to be ways to extend into different kinds of alert processing? Are there going to be other types of ways, not only for safeguard or copy, but to feed into your security intelligence overall, things of that nature? Are these feeds, again, going to be augmenting your overall security intelligence? And are they expandable to address additional input feeds and attack vectors in the future? So things to think about, things that have come in to discussion with our teams and from lots of different clients with regard to the SOD and how things are going in this space. But this is, I think, the crux of the questions around what AI anomaly detection could mean on zOS, and to invite that thought process and attention of, in the future, wherever you would decide to go of how to implement this to your overall security and resiliency posture.
So we've got Clam AV then for like the likes of Linux and stuff, the open source malware detection freebie. So could we call it something like Clam zOS maybe?
I probably not. I must admit, like for much of my product management, it's been in the base level of zOS security. Going through the naming process of creating a new offering. That is a very interesting experience. Pretty sure the marketing folks are not going to let me use the word Clam.
And I do remember those days, Brian, very well when I was product manager. Yeah.
Yes, indeed. But thank you. Okay, so I'm going to keep going. So now let's start to segue and say, all right. So we've seen the history of ransomware on distributed systems. And we see the analogy of NIST and the cybersecurity framework and this convergence of, let's say, traditional security with resiliency. We know that anti-malware is making its way into the regs in a beneficial way. But once you've got the AI for detection, you still have to determine what does quarantining mean on zOS. And so what function exists today, and I'll just give the heads up, this is probably not going to be sufficient for what we need. But here is some interesting information from Chris Meyer and ComServer of what is this today. On the network side, there is this concept of IP packet filtering at the zOS IP layer, right? So you can have these filter rules based on relevant attributes, and it can be from a local or a routed traffic perspective, and your possible actions for when a filter rule is matched, you can be a permit or a deny. But what's I think particularly interesting for this topic, they also have this notion of defensive filters that they can be created dynamically through the IPsec-F command. So they manage these through these DMDs, these defense manager daemons. They can be used by network management or even your SIM automation. So you already have this integration with your security intelligence. They're definitely a deny-only situation. There is a simulate mode that's possible, but they are installed in front of all your planned filters. Right? They're maintained on DASD to protect against a restarted stack. They're designed for a limited lifetime, let's say around 2 weeks max. You get selectable scope, whether you're going to be a specific stack or the entire system in case you got multiple stacks within a given image. And you got one DMD per system that managing these things. So from an IP perspective, you have these controls in place that you can dynamically deny traffic when there's concern. But we might not be starting here with regard to our early look into what quarantining is going to mean. So we're looking at RACF, and let's explore a bit what quarantining might mean. Here are some considerations for possible enhancements as we're exploring what's the best route to take with regard to this statement of direction. One, we felt pretty early on, it's this nice clean break in the design to say quarantining makes sense as a role or a function for the external security manager. And we have had some early discussions with our friends at Broadcom, so that we have the capabilities agnostic to whatever ESM you have. But it kind of made sense that if you're putting out an offering for this AI anomaly detection, and there might be other offerings coming out of the ecosystem for your consideration as well, then here quarantining kind of belongs here. So that's where we're starting with RACF. We look at the way in which user IDs are revoked today, and thinking about a possible extension. Currently, when a user ID revocation occurs, it's largely pending a user's logoff. Now you can force them off TSO. And in Kix, there was a relatively recent functionality added that they will listen for an ENF signal on user ID revocation, and they will force them out of the Kix environment, which is a cool thing. But it's somewhat problematic to know all possible applications that could be, leveraging RACF verify processing. And so a potential extension here, well, what if there is a quarantine or a special revoking flavor that also fails subsequent rack route auth and fast auth requests? So in other words, traditional RACF user ID revocation is pending log off. So it's pending in the RACF database. But what do you do for a user ID that is still there on the system? And if you want to quarantine them immediately, a possible way to centrally do that, we can put the note out, the message out to all the ecosystem out there and say, you may want to consider added actions when we put in this special quarantine style of revocation. But what we can do centrally is say, well, any subsequent auth or fast auth for this user ID is going to fail. Now, with regard to extensions to the programs themselves, if you look at the program class, you have this control today, which restricts fetching. But we've had this question, well, what about the programs that are already up? What about common memory? What about the LPA section where it's there, it's resident, and it's available to all address spaces? So one of the things that we're considering is this possible extension of dynamically making a program non-executable. So a non-trivial task, to be sure, and certainly a very powerful command to be protected very strongly. But it's something in between the extremes. Like if you are dealing with a cyber attack post-incident situation and you are looking to make this tough choice of maintaining availability, but managing the risk. One extreme would be, well, we'll do what we can on the user IDs, but we'll keep all the programs running for the sake of availability. The other extreme, you don't know to the extent or see that the extent of the damage could be substantial, and you could consider weight stating an entire system. The ability to make a single program non-executable would be something in between. But for quarantining both user IDs, programs, what have you, we have a lot of considerations for how that would be managed. System special comes to mind in terms of what kind of RACF admin is going to be able to issue this kind of command, and perhaps special case profile requirements so that you didn't need full system special, but it's certainly not for your typical help desk user ID resume type of processing. You want to have the functionality to reverse these commands in case there's a bit of a reversal on the decision, for example, or and for whatever reason that might occur. And then also this notion of trying to anticipate what post-incident response is going to be like. And what kind of planning might you do up front that you might have exclusion lists for these things as well. If you knew up front that you have certain service IDs or certain critical programs that would do more damage to your system to quarantine, then perhaps up front you make that business decision to exclude them from this processing, so that in the heat of the moment, when you are trying to react to, let's say, a cyber attack on zOS, then the exclusion list that was planned previously that gives you that upfront information that says, no, this is not a viable option for this particular user ID program. So that's some of the considerations that we're putting out there. Like I said, nothing finalized at this time. Certainly welcome any kind of feedback and questions that people might have. And from here, we come full circle and back to Anuja to say, okay, so this is what we've been unpacking. And this is basically the meaning of this SOD, that when we are looking to create the first ever anti-malware for zOS, we are looking to improve your overall security posture with the addition of AI security in the nature of anomaly detection, and to also add quarantining functionality into the external security manager, so that you have an overall strength of posture there with a more complete end-to-end look from security to resiliency, and with the nature of that detection and added mitigations. So from here, I will say thank you and open it up to further questions. Here's our trademark page and session feedback to make sure we have that in there for the session code of 8J. Looking forward to hearing from you. But we have a couple minutes left. If anybody has any kind of questions or feedback on the session today.
Thank you so much for that, Brian. Gosh, there's a lot of good stuff for the sounds of it in the cooking pot there. So look forward to some of that coming out. So we do have a question. I'll just read out. And folks, your lines are unmuted now, by the way, so you can throw a question to us live if you want, or post them in the chat. But the question that's come up is, are you planning to somehow share, e.g. ship with zOS, IBM gathered AI models helping to detect the anomalies and make them available to customers, or is each customer supposed to train their own models themselves?
Oh, that's a very good question. So I won't discuss like whether or not or a time frame for the AI framework perspective, but I will say the notion is that we're going to gather in this data, and this is going to be a self-training kind of situation. It takes in the new data that over a span of time, it does become customized to your environment. So, like I said, there could be some tweaking as we look at various tuning possibilities, but the foundation of this is it's going to teach itself based on the SMF data on how your enterprise works.
Thank you. Any other questions from any of the folks out there? Like I say, you can unmute your line if you want to throw a question in.
Brian, this is Sam Reynolds from ComServer.
Hey, Sam.
I just want to elaborate and make a couple of points on your answer earlier about the SNA and VTAM relationship.
Thank you kindly.
You answered well, but what I would like to distinguish is between native SNA and what I would call modern SNA. Modern SNA being Enterprise Extender and TN3270. The latter two are very securable, using IPsec and ATTLS for TN3270. We have no plans to enhance the session level encryption that can be used for native SNA. Very old, we don't plan to enhance it. But as the world completely moves closer and closer to modern SNA, we don't think that's a big issue. The other question was asked was about policy enforcement. Policy enforcement is a TCP only function at the moment. It is, even though ZERT collects enterprise extender connection data, policy enforcement doesn't apply to it. If customers think that's something they would want or need, someone could open an idea about it. We currently don't have one. It's not really on our radar right now. But from a SNA perspective, TN3270 connections or TCP, they can, policy enforcement can apply to them, but it does not apply to EE. And so that's something to keep in mind.
Awesome. Thank you very much, Sam. Absolutely, the clarifications I was going to be following up on. It's great to get it here live, and I definitely owe you an avatar card.
Thanks, Brian.
Thanks, Sam. Okay, so we've got 1 minute left. Any final questions, thoughts from anybody before we close up? And by the way, folks, I mentioned ClamAV. In the spirit of GSE, other antivirus solutions are available out there, by the way.
Thanks, Jay.
Right, so thank you, Brian, for that. It was a really good session. Nice to, like I say, some of the innovations you're thinking about is very, very interesting developments. And I look forward to that day when the next kind of QSA into PCI land, or an auditor or someone who's doing a compliance test asks that antivirus or anti-malware question. We might one day be able to say, yes, we do have a solution.
Indeed, indeed.
Yeah. Yeah. All right. So thanks, folks, for joining us today. So a couple of things before you go. We haven't finished for the day, by the way, so we've got a 30-minute break. So at 3 o'clock UK time, we are back here in the security stream with Mark Nelson, who many of you know. He's going to give us a RACF update, so we're looking forward to that. Of course, there are other sessions going on in the other stream, so pick the one that best suits you. But of course, we'd love to have you back in the security stream. So do join us for that. Don't forget, as Brian has up there on the slide right now, don't forget to do your feedback. You can either use the QR code that he's kindly put in there for us, or go to MyGSE. You can also go to the agenda, and if you're signed into me at MyGSE, click on the feedback link, and that will automatically populate your details, and you just give us that feedback. But like I said, very important, if you're collecting CPE points and you want that CPE certificate, which a lot of security people do now, that will not get generated, that certificate, until you've given your feedback. So there's the incentive there for you. Right, so look forward to seeing you in 30 minutes, whatever session you choose to go. And Brian, lovely to see you again. You're back tomorrow with us, aren't you? With
Yes, indeed.
Another session, so we look forward to that. And for everybody else, enjoy coffee break, and see you in 30.
Okay.
Thank you.
Bye.
Thanks, Brian.
Thanks, everybody. Bye.